Hey guys, how you gone? It's Rashid Hashmi from Doctors Digital College. Here you will get video lectures on different topics of A levels and O levels Cambridge International Examination, IGCSE, GCE, F.Sc and Metric, entry test of different subjects being taught in Pakistan, India, Bangladesh and Sri Lanka. Hope you will enjoy it.
Welcome to Doctors Digital College.
So, in this lesson we will study about respiration. In this topic we will be studying what is meant by respiration and what's the difference between internal and external respiration or ventilation, and what are different stages of the respiration and what different biochemical processes are occurring in the first stage of respiration called glycolysis. So let's start with respiration. In your previous classes, you have already studied that respiration is basically the oxidation of food, whereby we oxidize the food to get energy. Although there is energy in food, but we are using different kind of food, carbohydrates, proteins and lipids. And energy in these different kind of foods cannot be directly used for different body activities. So first of all, chemical energy of food is converted into ATP energy, which is then used as a currency for a variety of different body activities. And what is this respiration? This is, here you studied in your previous classes that if glucose joins with oxygen, it produces carbon dioxide, water plus energy. This is the word equation of respiration. And first of all, let me clear, why are we always writing the respiration of glucose? Is there no respiration of fats, lipids or different proteins? Yes, there is. There is the respiration or there is the oxidation of different other food products. But in general, 80% energy for different body activities is coming from the carbohydrates, and the most common carbohydrate which is being oxidized in almost all living cells is the glucose. So there is the oxidation of fats and the proteins, but there is major oxidation of food is that of glucose. Moreover, glucose can be oxidized in the presence of oxygen or even in the absence of oxygen. But fats and proteins, they cannot be oxidized if oxygen is not available. So this is the most favorite food which is being oxidized in almost all living cells. That's why we are always writing glucose oxidation. And if I write its symbol equation, then it is like this: C6H12O6 plus 6O2. And it is, when completely oxidized, it produces 6 carbon dioxide, 6 H2O and about 38 ATP. This is an ideal equation whereby every carbon of the glucose and every hydrogen of the glucose is ideally oxidized into carbon dioxide and water, and theoretically 38 ATP are produced. And this is a molar equation, means when 1 mole of glucose is oxidized by the 6 moles of oxygen, there is the formation of 6 moles of carbon dioxide, 6 moles of water and 38 moles of ATP. There is never carbon dioxide produced as the only product. There is never water produced as the only product of oxidation. Sometimes there is lesser oxidation, mean hypoxidation of the food is there. Sometimes there is hyperoxidation of the food is there. So when we will go to next of this topic, you will come to know that what are other different byproducts or the waste products being produced along with these two products. Okay. Moreover, 38 ATP molecules are theoretically produced at maximum, but in the real production of ATP is about 32 ATP, and rest of the ATP molecules, they are used in the transport of different materials within the cell, from cytoplasm into the mitochondria and from mitochondria into the cytoplasm. So about 32 ATP moles are produced per mole of glucose. Okay, after this basic introduction of respiration, let's see what are different stages of the respiration. This respiration is not a single step reaction. It's a complex reaction and is comprised of hundreds of different biochemical reactions. And this is a continuous process. There are no stages in the process of respiration, but just for easy to study, we have divided respiration into 4 different stages. What are those 4 different stages? Number 1, it is glycolysis. Number 2, it is link reaction, or it is also called oxidation of pyruvate. Then the third stage is Krebs cycle, and the fourth stage is oxidative phosphorylation. It is also called electron transport chain, or simply I can write it is ETC. Okay, so these are 4 stages we have developed for our easy to study: glycolysis, link reaction or the oxidation of pyruvate, Krebs cycle, and oxidative phosphorylation or electron transport chain. Now let's see what is happening in all these 4 stages in general. In glycolysis, glucose is broken down into pyruvate, and along with the pyruvate there is the formation of 2 ATP plus 2 NADH2. Later I will tell why it's not true way to write NADH2 and what's the other way. This glycolysis, the first process is occurring in the cytoplasm of the cell. Then in the link reaction, this pyruvate is oxidized, whereby pyruvate is changed into acetyl coenzyme A, and along with it there is the formation of 2NADH2. Okay, and in the third step, that is the Krebs cycle, this acetyl coenzyme A is changed into 2 carbon dioxide, and there is the production of 3 NADH2, 1 FADH2 and 1 ATP. And in the last step, oxidative phosphorylation, what happens that all these chemicals, NADH2 and FADH2 separately, they are reacted with molecular oxygen to be changed, to be oxidized into NAD or FAD, along with the formation of 3 ATP and 2 ATP, plus with the formation of water, like this. Means NADH2 or FADH2, which are produced during different stages of glycolysis, link reaction, Krebs cycle, they are finally oxidized within the mitochondria by using molecular oxygen, whereby NAD is oxidized into NADH2 is oxidized into NAD, FADH2 is oxidized into FAD. Here, by the oxidation of NADH2, 3 ATP moles are produced, and by the oxidation of 1 mole of FAD, 2 ATP moles are produced, and there is the formation of water molecules. This is the overall sketch of the process of respiration. Here we will see that what are different biochemical processes occurring in this process of, in the first process of respiration, that is glycolysis. Now, glycolysis, the first stage which we have developed of the cellular respiration is glycolysis, and from its name it's clear that it is the lysis of glyco. Glyco is a conventional word used for the glucose, and the lysis means breakdown. So glycolysis is the breakdown of glucose. If I write the net result of this, in this case C6H12O6 is broken down into C3H4O3 along with 2NADH2 and 2 ATP. These are 6 carbon and these are here 2 of this produced, means this is pyruvate. 2 of 3 carbon compounds are produced out of 1 6 carbon compound. So a 6 carbon compound has been lysed, has been broken down into 2 of 3 carbon compounds. So this is the overall process, and this is occurring in cytoplasm of the cell. And you might have seen that for the oxidation of glucose, here NAD, nicotinamide adenine dinucleotide, has been used. It has been reduced to oxidized glucose and no molecular oxygen has been used. So the first process of respiration, glycolysis, will be occurring even if oxygen is not available. Oxygen is available, glycolysis is occurring, and if oxygen is not available, even then glycolysis is occurring. And this is a very specific process only for carbohydrates. This process is not in the oxidation of fats and proteins. Okay, now let's see what is occurring overall in this process. This is once again is not a single step reaction. If I try to divide it into different stages, then the first stage of glycolysis is preparatory stage or preparatory phase. This is also called providing activation energy to glucose. And the second stage is lysis stage. The third stage is oxidation stage. And the fourth stage is substrate level phosphorylation. Substrate level phosphorylation process. Okay, now we will see what is happening in all these different stages of the glycolysis. As it's clear from the preparatory stage that this highly stable compound glucose is prepared for the oxidation, or during this process oxidation energy is provided to glucose. Now let's see how is oxidation energy is provided. If I write here glucose like this, the soluble form of the glucose is the cyclic form, it will uptake 1 phosphate from 1 ATP to be changed into glucose phosphate. This is here glucose phosphate. 1 phosphate is attached here at this point. With the carbon number 6, 1 phosphate is attached. And along with it, there is the production of 1 ADP. Means 1 high energy phosphate bond is broken down and is attached with the glucose. Means we have provided some energy to the glucose to make it reactive. Now, still it's not very much reactive. Still it needs some more energy to be activated for its complete oxidation. So first of all, it is converted into its isomer that is fructose, whereby one phosphate is already attached with it here, and now with this fructose one phosphate is attached, one more phosphate is attached here. If I write here like this, plus 1 ATP, then it will be changed into like this. The compound formed is fructose 1,6 biphosphate, and along with it there is ADP formation. Now this fructose 1,6 biphosphate is highly reactive. It's highly unstable compound. And you might have seen that in the first process or in the preparatory stage, we have consumed 2 ATP molecules, or in other words, for 1 mole of glucose, we have consumed 2 moles of ATP, one at the first stage, one here at this stage. Now this compound, fructose 1,6 biphosphate, this is a hexose, an isomer of the glucose. This is ketohexose. This is aldohexose and this is ketohexose. Now this will go into the next stage, that is called lysis. Okay, just to continue the process, I will be writing it here along with it as the second stage, that it is broken down into 2 compounds. One is called acetone phosphate and one is glyceraldehyde phosphate. This is aldotriose, this is ketotriose, means this 6 carbon compound, which is here, I am writing here 6 carbon compound, this has been broken down into 2 3 carbon compounds. This is a 3 carbon compound, this is a 3 carbon compound, and the phosphates have been distributed, one to the acetone and the other to glyceraldehyde. Now acetone itself is highly unstable because ketones overall, they are less stable than aldehydes, and smaller the ketones, less it is stable. So what happens, that acetone phosphate is changed into glyceraldehyde phosphate. So if I write here like this, if I make it dotted line like this, that initially 2 trioses are formed, one aldehydic triose and one ketonic triose, but this ketonic triose is then changed into aldehydic triose in this lysis process. So I can write that we will get 2 moles of glyceraldehyde phosphate by the breakdown of 1 mole of fructose 1,6 biphosphate. Now, sometimes this is also called phosphoglyceraldehyde or PGAL. We can write here phosphoglyceraldehyde. Sometimes it's also denoted as PGAL or phosphoglyceraldehyde. And this is overall happening in this process of lysis, the second stage of glycolysis. Still there is no oxidation. We have not produced any energy because yet there is no oxidation. Glucose has been activated by providing energy, and then it has been broken down into 2 compounds by this lysis process. Now the actual oxidation of glucose will be started with this oxidation state. Now what is this actual oxidation state? If I write here in short way that this glyceraldehyde phosphate will be changed into glycerate biphosphate. If you look at this, this is glycerate and this is aldehyde. The formula, the general functional group of aldehyde is C double bonded OH, while the functional group of glycerate is C double bond OOH. Now what's the difference between the two? Here there is no oxygen and here there is oxygen. So this is the actual oxidation whereby aldehyde is oxidized into carboxylic acid. This oxygen is coming from the breakdown of water. There is no molecular oxygen yet being used. So this process is using oxygen from water, and during this oxidation process a lot of energy is produced, which is used to break down water, as well as that is used to reduce NAD. And there is also the formation of 1-phosphate bond. Now let's see in detail that what is happening by the oxidation of glyceraldehyde. We were talking about the oxidation of products of lysis of 6-carbon compound. We saw that it is here glyceraldehyde phosphate produced, which is also called PGAL. This is a 3-carbon compound, and this is a ketotriose. If I write its functional group is like this. It is oxidized into glycerate biphosphate. And this is also a 3-carbon compound, but its functional group is C double bonded OH. Means the difference is 1 oxygen. Glyceraldehyde is oxidized into carboxylic acid or glycerate biphosphate. The difference between the two is 1 phosphate is also extra. It is here single phosphate, it is here 2 phosphates. From lysis we got 2 of glyceraldehyde phosphate, and here 2 of the glycerate biphosphate will be produced. Where is this oxygen coming from? You can see in this process there is no molecular oxygen yet has been used. And we have already discussed that in glycolysis there is no oxygen. This is the overall process of glycolysis, and no molecular oxygen, the oxygen which we have inhaled, is not being used. So this oxygen is basically coming by the breakdown of water. During this oxidation process, a lot of energy is produced. This is an exergonic reaction or exothermic reaction. Energy is produced which is used for the breakdown of this water. Oxygen of the water is used for the oxidation of glyceraldehyde, whereby the 2 hydrogen and some more energy is taken away by NAD, which is then reduced into NADH plus H positive. When glyceraldehyde is oxidized, NAD is reduced. As 2 of the glyceraldehyde are being oxidized, 2 of the NAD are being reduced, and 2 water. Means we will multiply whole of the equation with 2. Now one thing more is there. It is here single phosphate and it's here 2 phosphate. So there is also the attachment of 1 phosphate. 1 phosphate is also inorganic phosphate. This is also getting attached from the cytoplasm, which is produced by the breakdown of ATP. Inorganic phosphate is attached here to make it biphosphate. Now aldehyde triose has been changed into carboxylic acid. You will come across the same chemical reaction exactly opposite in direction during the process of photosynthesis, whereby some carboxylic acid is reduced into the world's first sugar, that is a triose or a triose phosphate. Okay, and this is overall process of oxidation that we will be getting 2 glycerate biphosphate and 2 reduced form of NAD. Now the next stage is substrate level phosphorylation. It's clear that there are 2 phosphates attached here, and the 2 phosphates are removed one by one to produce ATP. Now let's write them here like this. It is here 2 glycerate biphosphate. It is changed into phosphoenol
pyruvate, and then it is changed into pyruvate.
I have omitted some of the intermediate processes just to show the net product, those reactions during which energy is produced. It is here biphosphate, it is here single phosphate, and it is here no phosphates. So these two phosphates are removed one by one, and these two phosphates are used here for the formation of ATP. ADP will take up one phosphate from here and it will be changed into ATP. Same is here, that one ADP will uptake one phosphate from here and will be changed into ATP. If I multiply whole of this process into 2, it is here 2 of it, it is here 2 of it, and then it is here 2 of it, 2 of it, 2 of it, and 2 of it. We are getting it like this. Okay, so as a net result, we have got 4 ATP, 2 ATP here, 2 ATP here. And the 2 ATP we had consumed during preparatory phase, and 2 of the NADH2 have been produced, means they have been reduced. So this is the final product of glycolysis, and this product glycolysis, after glycolysis, which was produced in the cytoplasm, will go into the mitochondria and where it will be oxidized. Now we will see in the next lesson that how is pyruvate oxidized into acetyl coenzyme A, and then acetyl coenzyme A is oxidized into carbon dioxide during Krebs cycle. Hope this first stage of the cellular respiration, that is glycolysis, is very much clear to you. Guys, hope you have enjoyed this lecture and you would like to have many more of similar lectures for other subjects by subscribing my channel, Doctors Digital College, or you would like to log on to www.doctorsdigitalcollege.com.